All right. Okay, so properties of 0. What is 999 times 0? 0. Yay. Negative 400x equals 0. What does x have to equal to? Yeah. So if we know two numbers, their product is 0, and we knew one of them, the other one had to have been 0. Does anyone know what 0 times 0 is? Yeah, it's actually nothing special. It's just 0. Okay? So this is basically what you're going to learn about why x-intercepts are also called zeros. That's where we're going to use this 0 product. This whole property of 0, that anything times 0 is 0. That's why an x-intercept is going to be called a 0. So you'll see in a second. If you have a times b equals 0, okay? A times b equals 0. That means what? What can you conclude? So you said one of them is equal to 0 or both are equal to 0, right? If we know there's a product of two numbers that equals 0, it could either be that one of them is 0 or both are 0. But somebody has to be 0. And so we're going to use that today. So if I look at this here, I'm just going to zoom in a lot larger. X plus a times x plus b equals 0. Okay? So if we know this product is equal to 0, everything we do is going to be based on this. That means that either, would you agree, that if this product is equal to 0, either x plus a equals 0 or x plus b equals 0? Or could it be both? So it could be and. Or and, right? It could be both. Either they're both equal to 0 or, well, and that usually is the case if they're the same. So if x plus a equals 0, what could you say x is equal to? No? If x plus a equals 0, that means x is equal to what? What value of x would, if I want x by itself there, if I want to isolate x in this, how would I isolate x? Subtract a. And 0 minus a is just negative a. Would you agree with that? So if x was equal to negative a, would that make 0? Would you agree that negative a plus a gives you 0? Yeah, that would be a 0. Okay. Or if x plus b equals 0, we could say then x would equal to, we isolate x, negative b. Would you agree that negative b plus b would give you 0? Yeah, and so with that product, either of those, if it was x is equal to negative a, your product would be 0. Or if x is equal, no, it would only be one at a time. So I should actually write this. It's either going to be negative a plus a times negative a plus b. Would that give me a product of 0? It's very abstract. Yeah, because 0 times anything, doesn't matter what's in the second bracket, does that give you 0? Yeah, 0 times anything. Or if x was equal to negative b, this is very abstract right now. So if I replace all my x's with negative b, would that give me a product of 0? Yeah. So it would be negative b plus a, whatever that equals, times 0. And anything times 0 is 0. So that's how we're going to actually use the factoring to solve for those x-intercepts. To solve for the zeros when y is 0. So looking at this, for example, it says solve this guy. It's already factored for you. Okay, it's a product of two things. So either the first one is equal to 0 or the second number is equal to 0 because we know the product is equal to 0. Do you see that? So if, well, x equals 0, that's one option. There's nothing to do there. The other side, what would x equal to? 7. So our solution would be if x was 0 or 7, either one of those would give you a product of 0. Okay, let me show you. Let's check this. If x is 0, we're not going to check this every time. Okay, just this time. If x was 0, I'd have 0 times 0 minus 7. Or 0 times -7, does that equal 0? Yep, sure does. Okay, if check for x equals 7. So if we had 7 times, I'm replacing the x in the actual equation here, 7 minus 7. Or 7 times what? 0. What's 7 times 0? 0. So these are the two values of x that when we sub them in, they're going to give me 0. Okay? Now, could I kind of just look at that and see that? Kind of, yeah. So our first step, let's look at number 3 before we go to 2. It's already in factored form. What values of x would make each one of these 0? 1 and 6, right? Can you just look at that and see 1 minus 1 would give me a 0, or 6 minus 6 would give me a 0? Yeah. Okay, so that would be my solution. So once we have it in factored form, all we have to do is figure out the value of the x that would make that bracket equal to 0. That's it. Let's go back up to number 2. So to solve, every time we solve, what's our first step? One side equal to 0. Okay, our first step is to make one side equal to 0. Our second step is going to be factor if possible. Okay, we're going to add a third step. If we can't factor, then we're going to use things like the quadratic formula or completing the square, one of those two methods, either or really. Usually quadratic formula. That's for when you can't factor. So today's lesson is when we can factor. So all the examples you have should be factorable every time. Okay? So if I isolate we always want to keep x squared positive because it's not, I don't know. Your leading coefficient should be positive because you could bring the x squared to the other side and then have negative x squared, but then you're dealing with a negative. So how do I factor x squared minus 3x? How do you factor that? You can do the complex ones, but you're given the simple ones. Sometimes you forget. Not a difference of squares. Can you square root both of them? No. But it is two terms. So we just have to check for very basic. First step in factoring, greatest common factor. What's your GCF here? X. So we're going to factor x out, and we're left with x minus 3. Okay? So what are the values of x that would make this product 0? 0 and 3, right? You look at each separate thing. Well, x doesn't have a bracket, but basically at each set of brackets, right? There's two things being multiplied. The first one, either x is 0 or x minus 3 is 0. You with me? Sort of, you're just saying that. Are you getting how we go from here to here? That's the most important part. No? Yes? Got a yeses? Okay. Okay, let's look at 4. So first step. One side equal to 0. You guys still are tired today, but not as bad as yesterday. Yesterday was special. Okay, so we get one side equal to 0. Second step. Factor. Okay, two numbers that multiply to positive 6, but add to negative 5. Negative 3 and negative 2. Okay, so you should get to the point, especially with these simple ones, that you can go straight to factored form, right? Because you know it's going to be 1 and 1, or x and x. And so with the simple ones, you just know it's your two numbers, multiply to the last, add to the middle. Right? Every time. 1, 1, 3, 2, negative, negative. Okay, so x minus 3, x minus 2. So what values of x would make this product 0? 3 and 2. Okay? All right. Everyone got that? Like zoomed in big time today. But I kind of like it. This guy, why don't you try? One side equal to 0. Two, 1, 3, 1. You want to add to a positive 1. So we have a positive 3 and minus 1 there. That gives you negative 2, positive 3, right? That adds to 1. Okay. Did you get that far? 2x plus 3 times x minus 1. So, what values of x would make this product 0? So we're looking at each one individually. Did anyone figure out the first one? How about the second one? 1. Okay, so we got that one down. We know, okay, x is equal to 1 would make that one 0. Now, how could I figure out this guy? It is a fraction. Close? Yeah, you're right. Okay, so 2 times 1.5 would give you positive 3. So negative 1.5. You're right. Because, right, we know that, and so when we have these ones that are, there's a coefficient in front, we know 2x plus 3 equals 0, right? That's what we're trying to solve. When does 2x plus 3 equal 0? Well, how do you isolate x here? What would you do first? Subtract 3, and then divide by 2. And would you agree that's equal to negative 1.5? Yeah, it is. Okay, so negative 3 over 2. So when there is a coefficient, okay, notice the little shortcut. When we had x minus 1, it was equal to positive 1, right? It was the opposite sign. Agreed? That would make it 0. 1 minus 1 would give you 0. If it was x plus 1, right? If one of them was x plus 1, what would it be? That would negative 1, right? It's the opposite sign. So when there is a number in front, so when you have, oh, that is not an eraser. Let's try this again. When your factored form is, say, let's call this, I don't know, ax plus b. Okay? If one of them is ax plus b, then the solution would be negative b over a. Negative b over a. Because you're subtracting b and then dividing by a, right? So if you're isolating, because really what you're getting by yourself, what you're trying to isolate is the x. If we have ax plus b equals 0, subtract b, divide by a. So the shortcut, opposite sign of what you see here. So this is a plus. So notice our solution is a negative. And then second over first. The 3 over the 2. B over a. Okay, so 3 over 2. Because you're subtracting 3, then dividing by 2. Okay, that's kind of the shortcut. So our solutions here were, if you had it as a decimal, that's fine. Negative 1.5 and 1. That would be your solution. Okay, so solutions here, I would make this 0. Now, could I check my work if I wanted to? Yeah, just go back to the original. Let's use my calculator really quickly. In fact, you can even store. Do you remember how to store numbers as letters? Stove. Yeah, it's like a cool lingo or something. So you choose you put your number. So 1 STOX, so store it as 1, is 2x squared plus x equal to 3. Yes, that's correct. And then I could go negative 3 over 2 or negative 1.5, store that as x, is 2x squared plus x equal to 3. Yes, those are my solutions. Checked. Okay? Easy? So did you see how you have to know how to factor today in order to solve? Why don't you try 6? And if you're feeling up to it, you can try 7 too. Sort of okay? So that would be the solution there. You should have had 7 and negative 5. This next guy, could you guys start it? Yeah? What would you have to do for number 7? Distributive property in FOIL, yes. So remember that this, I'm just going to rewrite this out. When you have x plus 2 squared, how would you write that written out? X plus 2 times x plus 2, good. Right? We'd have to multiply it by itself. So we're going to use some distributive property with the first set of brackets. That would be 6x minus 10. And we have to use what with the second set of brackets? FOIL. Okay, so x times x squared, x times 2, 2x, 2 times x, 2x, and 2 times 2, 4. So before I get one side equal to 0, I probably want to collect like terms here. We have x squared. How many x's would you have? 10. 6 plus 2 plus 2 gives you 10. And then your constant, you have negative 10 plus 4. You're ahead of me. Minus 6, and then equals 18. But we need one side equal to 0, so you'd have to subtract 18 and then factor. So once you have everything to one side and simplified, now you factor this. Okay, two numbers that are going to multiply to negative 24, add to positive 10. Negative 2 and positive 12. That would do it. Okay, so we'd have x minus 2 and x plus 12. And what does that equal? 2 and negative 12. Okay, we're going to add one more question before we turn the page. Just add a number 8 here. So if you had factored form, 3x minus 2 times 4x plus 1 equals 0. Write the solutions to that. I want you to practice one more where the code, like those were all easy factors, so write would be the solutions to those. What values of x would make that 0? Okay. So 3x minus 2 times 4x plus 1. I'm going to show you a shortcut. You can use that. If you don't want to use the shortcut, you can set each factor equal to 0 and solve. Right? We know either 3x minus 2 equals 0 or 4x plus 1 equals 0. No. Is he not in his room?
I had a gift for you.
Oh.
He's the ultimate fan.
Oh, man, he's going to love that.
He might like this.
He's better like. Okay, what did you get? Did you get the first one? X is equal to what? Anybody? Jane? No? Negative. So the first one's going to actually be a positive. Oh, yeah. So 2 over 3 would be the first, and negative 1/4. So the opposite sign, second over first, right? Because if x plus minus 2 is equal to 0, we add 2. So you can do the long way if you want. And then divide by, 3. Then divide by 3. Okay, same idea here. Subtract 1. Then divide by 4. Negative 1/4. Okay, so if you want, you can set each factor to 0 and just solve for the x. Or if you're able to just look at it, right, the shortcut, opposite sign, second over first. So because you're adding 2 to the other side divided by 3. Subtracting 1, dividing by 4. Okay? All right. Let's get to those word problems. Yay, I know, you think you're done. And then you're not. Sorry. Okay, I have to zoom out for this. The length of an outdoor lacrosse field is 10 meters less than the width. So this is a little bit different than the max-min problems, okay? When you have a max-min problem that we always had two variables. And we solved the maximum or minimum by completing the square. So that's what chapter 3. In chapter 4, we're going to solve quadratic problems. Okay, we're going to solve. So when you are dealing with a solving type problem, you're only going to have one variable. In order to solve, it has to be one variable. And this is where we're going to factor. Or, so one side equal to 0. We should write that one side equal to 0. Factor or quadratic formula, which you haven't learned yet. I just want you to write that down. Okay, the difference in there's two types of word problems. So if the only time you complete the square is when it's a max-min. It's asking for what's the maximum area, what's the minimum sum, right? Those are the type of problems where we have two variables, sum equals or revenue equals, right? And we completed the square. These ones we're solving. It's going to be an equation with one variable in the end. So one side equal to 0, factor. So let's look at this first guy. The length of an outdoor lacrosse field is 10 meters less than twice the width. Okay, write that equation. Let's use L and W. So length, what do you want to use for length? L? What is in math? Equals. So length equals, how would you write 10 less than twice the width? 2W minus 10. Whenever you have less than, it actually goes after what follows. So 10 less than twice the width, we get 2W minus 10. Okay? That's your first equation. The area of the field is, we're not maximizing area. This time we actually give you the area. The area is 6,600 meters squared. So how can I make an equation out of that? Pardon me? Oh, you're like way ahead of me. Okay, just with L and W. L times W equals 6,600. Perfect. Which now we're going to substitute, right? So our goal is to make an equation with one variable. That's what we want. We want to make an equation with one variable. That's our goal. So we're going to substitute. So instead, let's write this as 6,600 equals, what's our length equal to? 2W minus 10. I'm going to sub in 2W minus 10 for length, because that is equal to the length. So we're going to sub that in. Try and zoom in just a little bit more. Okay, so I'm going to replace that with 2W minus 10, because that's what my length is equal to. So replace that. Okay, so we want to solve for W. Notice we have one variable. What's our first step? Yeah, we're going to have to do that because we need one side equal to 0. You might want to use that's not the right word, distributive law first, right? Because we know our goal is to factor eventually. So you could just go straight to subtracting. It doesn't matter, okay? I'm going to use distributive property here. So 2W squared minus 10W. And then if you want to do it at the same time, that's fine. We have to get one side equal to 0. So we're going to subtract. It's essentially we're moving 6,600 to the other side. Okay. So when we solve, we should have one variable, one side equal to 0, and we always try to factor first. What can I do with this guy? GCF. GCF, thank goodness. Makes it a little easier. Never said easy, but easier. 6,600 divided by 2. 3,300. So that's what we need to factor. Anyone factor it yet? It's going to take some work. I'm just going to write it again up here so I have it. All right, 3,300. Well, you know that 33 times 100, right, is equal to, would you agree with that? So then 66 times 50, right? We have to look at our products. You might want to start. So we're going to, I know it's going to be in there somewhere. Did anyone find it yet? Right, 3,300 divided by 50, 66, but that's not a difference of 5. But also try, let's see here, 75? No. What? I'll try. Nope. It has to be between 66 and 50. Did you get it? 55 and 60? Yay. That'll do it. Okay, so 55 and 60. So this fact, the question is, who's going to be the plus and who's going to be the minus? 60 is negative, 55 is positive. So, we have this product. What values of W would make this product 0? Okay, positive 60 and negative 55. Can I reject one of those answers? Yes. Negative 50. Why do I reject this guy? It's a dimension. Cannot have negative width. Okay, can't have a negative width. So our width is 60. Can I figure out my length then? How could I figure out my length? Let's put it back into this formula over here. Length was equal to 2W minus 10, or 2 times 60 minus 10, which gives you what? 110 meters. So the dimensions are 60 meters by 110 meters. Okay, would that be a great written response question? Sure would. Oh, we have 2 more questions. I want to go through them pretty quickly. Is that okay? Ugh. Try not to be too quick. One whole number is 3 greater than 4 times another whole number. So let's use x and y. Okay? Keep it simple. One whole number is, how could I write that? 3 greater than 4 times another whole number. So let's be careful. One whole number is 3 greater than. Pardon me? Okay, if it's 3 greater, is it 3 times greater or just 3 greater? Is that a mistake?
No, this stopped working.
Oh,
Is there an actual secret to it?
uh-oh.
So what does that mean? Oh, how do you charge it?
I have this.
We're playing with new toys.
Here, so this goes into your speed, and then this just sits on this.
Oh, cool. All right, charge it.
Sorry.
No, I finished my lesson already.
It's lasted weeks. Oh, you're faster than me. Clearly. I need to go faster. Okay, this is a tough one. One number is, so x equals 3 greater than, right? Is equal to. One whole number is 3 greater than 4 times. How do you write that? 4y plus 3. That's the easiest way. Then it says, if the product, what's product? Multiplication, thank you. That's multiplying. If the product of the 2 numbers is 76, how could you write that? X times y equals 76. So what would we do next? Replace who? Replace x. So we're going to replace x with 4y plus 3 times y equals 76. Okay, notice we have an equation with one variable. So our goal is to get one side equal to 0. Before we do that, we have to expand. So let's go quickly. 4y squared plus 3y equals 76, or what's the next step? Minus 76. Okay. So I'm going to help you factor this quickly. Is that okay? Okay, 4 and 1. And 19 and 4. So that gives you 8 and 19. That doesn't. No, what's 4 times 4, guys? Thank you. 16 and 19, we want to make a positive 3. So it has to be a negative 16, so a negative 4 there. So 4y plus 19 and y minus 4 equals 0. So each one, let's do one at a time. The first one, y is equal to what? What's the shortcut? Negative, and then second over first, 19 over 4. Or this guy here, y minus 4, what value of y would make 0? 4. Can I reject one of these answers? And why do I reject negative 19 over 4? What type of number did it say it's going to be? Didn't say positive. Well, yes, actually you're right. It does say positive, kind of, because it's a whole number. And whole numbers are only positive. Yeah. So it can't be a decimal or fraction, and it has to be positive. So if y is 4, what's x? How do I find x now? Sub it in. So x is equal to 4 times y plus 3, which gives you 16 plus 3 is 19. So the two numbers are 4 and 19. Okay? Good. You could do that on a test. You okay? Okay, one more. And this question is such a good question. It shows up all the time. So we have to do it quickly. Okay? A 20-foot by 40-foot garden. 20 by 40. Is to be built so that it's surrounded by a walkway with an equal width around the border. So, do we know what that width is? No. What do you want to call it? W? Okay. So, if this W is surrounded all the way around, here, do you want me to zoom in more? Okay, zoom 300%. Okay, is that better? It should be drawn like equal width. Obviously, I did not draw this equal width around. Do not trust my drawings. The question I have for you is, what's this new long dimension? What would that be equal to? This right here. I think I heard it. No? No? Do we know the value of W? No. We do know that this here is 40. Just this much is 40. So it's 40 plus what? 2W. There's 2 W's plus 1 W here on this side and 1 W here. Okay, so 40 plus 2 W. This dimension right here, how much is that? 20 plus 2W. Okay. So it says total area with walkway is 1,500 feet squared. Can we make an equation now? Yeah. So area, which is 1,500, is length times width. What's the length? 40 plus 2W and 20 plus 2W. Now be careful. It looks like it's factored form, but it's really not what we want. Because what do we need when we solve? Equal to 0. So we're going to have to like FOIL it everything out, bring over the 1,500, and then go back to factored form. It's a pain in the butt. Okay, so let's do this quickly. 40 times 20. 800? Okay, that's okay. 40 times 2W, 80W, 2W times 20. Did I forget a 0? Yep. 80W, 40W, and then last, 4W squared, and that's equal to the 1500. So, can I do this all at once? Is that too much? I'm going to bring over the 1500 and also collect like terms. Doing two things at once. So 0 is equal to, let's write this in order, 4W squared. How many W's do we have? How many W's? 120. 80 plus 40, right? And then minus what? 700. Okay, there is a GCF of 4. We're doing this quickly. So when you divide that, you get W squared plus 30W minus 175. Which is nice, because then we have a simple trinomial, should be easy to factor. We need two numbers that multiply to negative 175 and add to 30. Yay! 35 and 5. Who's positive, who's negative? 5 has to be negative. Let's make a positive 30. Thanks, dear. So, W plus 35, right? Each row is a factor, and then W minus 5. Therefore, the width is either negative 35 or positive 5. Can I reject one? Negative 35 we reject. It's negative. So therefore, the width is 5. How do I get the length? Oh, there is no length. What do they want us to find out? The width of the walkway. There you go. The width is 5 feet. Done. We did it! I know, it took us a while. I'm sorry. Do now took a while. So the assignment for today is up on the board. It's 7 to 10 ABDF, and then 11 to 14 and 17. Back to number 2. Zoom out a bit. Is that good? Okay. So, yeah. I'm going to make sure a question like this is on your quiz, written response, okay? So make sure you can do your word problems. I want to practice those. It's right over in the chalkboard.